All right. I'll kind of interested in seeing how many people actually show tonight. What I've noticed over the 6 years that I've been teaching is that usually the first half of the semester tends to be fairly strong, and I usually wind up with like the majority of the class. I want to say at least 70% of the class showing up. And then it's like the break hits, and then after that, the first week after the break, I wind up with like a crazy 90% of the class showing up. And then every subsequent week after that, it goes way down, like absolute way down to like 9 people, 8 people kind of thing. And I think what it is just there's so much of a workload because a lot of the instructors have like pushed off projects, pushed off labs, and then now they're just like lab, project, every week, which kind of like nails you get down. Yeah, exactly. It winds up getting a lot more intense. It makes it difficult, so then you're starting to like selectively choose which class you're going to go to. That way you can catch up on your stuff, and you're like, Sean records his lessons, I'll just catch up later. But what I will tell you, it's kind of a bad strategy with this particular class because it doesn't get easier going forward. It gets considerably harder going forward. Tonight being one of those nights where things are quite a bit more difficult. So if you're going to skip any class, I don't recommend skipping this class. Or if you are going to skip this class, then I would definitely recommend catching up like as soon as possible, kind of thing, so that you don't get too far behind. Because this is a tricky one. This is a tricky class, or it can be tricky. I don't know. Some of you seem to already have kind of a bit of experience in working with JavaScript anyway, so I don't know. Maybe it doesn't make a difference to you. All right, let's talk about last week. So last week we did a real quick look at read-only APIs in Node. Thanks, Magnus. We talked about just reading data, right, and working with it, and you kind of got a little bit of insight into using model view controller systems, which is super cool. Even though we don't really have a view, it's kind of a view, right? When we make a response and we send that response back to the client, the response that we've created is our view, and that could be in a different format. Like we could take the data and format it slightly differently before we send it back so that it actually looks very different than the way it did in the database, but we're not doing that. We're just literally doing one-to-one kind of return. So we set up a Node app. We took a look at setting up Express, adding in our cores and stuff like that so that we can actually make requests to it using Hopscotch. We took a little bit of a look at Hopscotch. We're going to be using more Hopscotch today because we're going to build out an actual CRUD API now. So this will be create, read, update, and delete. And we will be storing this in a database, but not in MySQL or any type of relational database. We'll be using a NoSQL database. So it's different. I shouldn't say it isn't relational. That's always bothered me because when I first started learning about different types of databases and I got into it, and they were like, there's relational databases and non-relational databases. And I was like, what are these non-relational databases? And then they were like, okay, here's Mongo, and this is a non-relational database. But it isn't non-relational. You can use it non-relationally, but most likely are going to use it relationally. Because at the end of the day, data has relationships, and that's just inevitable. So you're going to want to be able to create those relationships. What it doesn't have, though, is those restrictions, those absolute strict constraints around it, like a relational database does. Yeah, exactly. I think all it means is you cannot associate a foreign key with non-relational. So you still can have keys, right? So Mongo does use identifiers, and you can create associations with those identifiers. It is a little different, though. Yeah, it's not really foreign keys. It's kind of foreign keys. Actually, you know what? For argument's sake, we'll call them foreign keys. But basically, the idea is that you can connect two tables together. So if you have a table called posts and a table called, they're not tables. If you have a collection called posts and a collection called comments, you can connect those to each other using their identifiers, their object IDs. Now, that being said, though, it's a bit different because we're going to use an ODM, which stands for Object Data Mapper, and the Object Data Mapper will actually do a lot of that type of relationship for us and allow us to be able to create those associations. Raw Mongo works a little differently. You can still store those things, but then programmatically you have to go pull them yourself. Anyways, we're getting way ahead of ourselves. The point is that we will be using a non-SQL database, so you guys will get exposure to a different type of database as opposed to a SQL database. Though that being said, depending on the job you get, in a lot of startups I've worked at, we use NoSQL databases. But moving into like agencies and stuff, it's always SQL. Even what's weird, and it took me a bit to get used to, is LMG. They use MySQL with a Node Express REST API. And I was like, that's weird, because most people when they're using Node Express generally connect it to Mongo. But no, they use a SQL database, and then they use something called Connects, which is a query language that allows them to be able to connect to the SQL and easily communicate with it, which is just a different approach. That's all it is. So we looked at setting up a Node application. We looked at pages, controller, and routes. We talked about how controllers work. Controllers are essentially, they're the middleware piece, right, that communicates between the view and the model. So they interpret whatever request is coming. Well, actually, the router interprets the request and fires it off to the controller. But the controller looks at the request and decides, I have all these parameters. This is the information I need to get from the database. I need to put that and assemble it together, and then I need to respond with that back to the client. So it always goes router, controller, client, router, controller, client. User submits a request, that hits the router talks to the controller talks back to the client again. Client makes another request, and that just keeps going around in circles and circles and circles. And then we created the super abstract logical router where we actually have our routing done at we have 3 points that we have to actually put our routes into in order for everything to connect up. We have our index file where the route actually first starts. Then we have the router loaded into like a compositional file where we actually load in our different resource routes. And then we have the specific resource routes defined under their own file. So I would have to say that out of all of the concepts that you're going to learn in this class, that abstract routing is probably the most difficult for most students. They have difficult following that train, so to speak, of code, connecting those 3 points. So I definitely recommend that if you haven't already, you should take your application and draw it out like in a diagram. Like, I'm not even talking like a legit flowchart, just kind of like diagram it out so you understand where things are connecting and you understand that flow. Okay, that's super important that you understand that flow. And then we have a characters model, controller, and routes, where we were like literally taking a route, creating it. Actually, we started with the model, right? We'd add the model details, then we'd add our controller, and we put the model into the controller and create our controller action. And then once that was done, we added our route to the resource routes, and then if we didn't already have that resource route included in our compositional routes, we did that as well. So at the end of the day, we had basically a small little Marvel API app, right? Super simple, nothing too extravagant. So tonight is a little bit different. Tonight is basically we're going to be building a CRUD API. Now the CRUD API is a little interesting because this lesson, when I taught it last semester, it took almost 3 full classes to get through. So it turned out to be bigger than I was expecting it to be. I don't think it will be quite that bad. I think it will be at least 2 though. So right now it says lesson 8, but assume that it's lesson 8 and 9, and at the end of 9 you will get your lab. So that's when you'll get the next lab, and the lab is called Appies and Nappies. Yeah, Appies and Nappies, standing for APIs, and I don't know what nappies are. Anyways, they're diapers, I think, actually. So we're going to be introducing Mongoose and Mongo tonight. We're going to talk about what an ODM is. We're going to create a model schema, which is basically just a description or a blueprint of what your model is. We're going to look at adding sanitization, normalization, and validation to that model. And then, providing we haven't burnt through the whole night, we're going to start creating our full REST API. So, This is kind of one of those ones where it doesn't really matter, and because you're the only class as well, it doesn't really matter what we use for an example. I'd kind of like to have two resources that depend on each other. So we could do blogs if you wanted to, and we could create posts and comments. I'm totally cool with that, and then we'll be adding a users table to it later on. So we'll actually have three documents, or three collections altogether. We'll have users, posts, and collections. That's fine. Or if you don't want to do something like that, we could do something different. We could do like books and genres, or music and genres and artists. I don't really care. Any suggestions? Or do you want me to just wing it? Movies? Yeah, we could do movies. Away says blogs. The rest of you don't really care. Whatever. Leo's like, whatever, dude. Just do something. I don't care what it is. I'll do it. Why don't we choose a thing. Movies and blogs. Alright, let's open this poll up. Alright, go for it. I love the fact that we're still 11/16 of no answers. Come on, who's going to win it? Oh, movies are getting bigger. It's like pitting students against each other. Fight. I think movies is going to take it. There's only 4 people who haven't answered. And likely aren't going to answer. I'm guessing. Yep, alright, so movies. Movies is what we're going to do. Okay, so if that's the case, if we're going to do movies, we need a relationship from the movie, so we'll do movies and genre, right? Does that totally work? So, like, for example, you could have action movies and then all the movies listed underneath that genre. So that's how we'll connect it up. And then for users, when we go to connect users to it, we'll make it so that the user can actually have a list of movies, like a playlist, essentially, of movies under their user ID, which will involve another collection called playlists. So we'll have kind of multiple little things, which is pretty cool. So let's get to it tonight. Tonight we're going to create 2 of the models. We're going to create the movies model and the genres model tonight, but in order for us to do that, we need a Mongo database. Now, I used to do this. I don't know why I say I used to do this. I didn't used to do this. I did it one time and learned my lesson after that one time. I used to install Mongo locally and have everybody install it locally, and we set up the Mongo servers, and then we would connect locally to our Mongo server, and then later on, when we went to deploy, we'd deploy to Heroku and set up a Mongo server on Heroku. Heroku has since changed the way they do things. You can no longer add a free Mongo database without a credit card. You have to have a credit card in order to verify who you are. And a lot of international students don't tend to have credit cards, so I kind of dumped that and tried to look for a different solution. I also dumped the idea of installing Mongo locally because a lot of people have like lockdown permissions on their systems, or they don't know enough about the back end of their computer to troubleshoot problems when you're installing something like a local Mongo database. So it led to a lot of issues where, when I did it, I spent 1.5 classes just resolving people's computer problems. And I don't want to do that because it's your computer and I don't want to solve it. So instead, we're just going to use online Mongo databases. The service that I use is called Atlas. They give you a free what do they call it? They call it not a cascade, a cluster. They give you a free cluster. You can have as many databases in the cluster that you want. However, you only get 500 megs of data. So don't go dumping tons of stuff into this because you're definitely going to be restricted, right? So it is free, which is awesome, but there is a restriction to how much space you can actually store on it. If you want to roll something different, like I don't know, maybe you have an Amazon that you're working with and you want to boot up an EC2 and do your own setup, that's totally fine too. I don't care. This is just what I'm going to teach. So I can never remember the name of this stupid website. I just know it's Atlas. Is this it? I want to say this is it. It looks it. Let's sign up with Google and see. I think this might be my Atlas. Yeah, I don't need that. I just need... How do I get to the thing? Get started, create an organization. Within an organization, you can create projects, invite users. I don't want to do that, though. This is not the thing that I've used before. Could have sworn it was called Atlas. It is called Atlas. Maybe it was in here that I did it in. Oh, right, because I didn't actually use Google. Stop! Let's try that again. There we go. Okay, so you guys are going to go to... Open link. Yes, this thing. Aha! Took me a minute. There you go. Okay, so you're going to go there and you're going to sign up. And I'm not going to walk you through how to sign up. Hopefully you can figure that out on your own. Awesome, I had a password already saved. Yeah, that's it. Because I never signed up with Google before, that's why. Cool. Alright, so go ahead, sign up. Keep in mind that it is going to send you an authorization code to your email, so make sure you sign up with an email that you actually have, because you're going to have to accept it. And then once you've accepted it, then you can go ahead and finish that off. Looks like my sandbox is still around. I don't think I have any databases. While you're doing that, I'm just going to go ahead and purge some of the stuff that I've gotten here. So that way we're setting it up together and it's not you guys doing it, trying to figure it out on your own. I think that's it. I don't have an LDAP set up. Cool. Awesome. And I don't have any databases set up. No, I don't. And just let me know when you're done. Just say done or whatever. That's totally fine. Actually, you know what? I'm going to create another poll. And then you guys can just click the button in the poll. I should use this thing more often. New poll. No, I don't care about that. No, I don't care about that either. There. When creating an account, I'm prompted to set the org name and project name and preferred language. Does any of this matter? Can I set to whatever? I think you can set it to whatever. I don't remember setting that up. That's why it kind of weirded me out when I saw it. I don't remember ever having to set up an organization. Oh, I did actually. Yeah, I have my own organization. Yeah, it doesn't matter because that's definitely Sean's org. There's no company called Sean's org. Yeah, set up whatever you want. I gave you a 5-minute time limit to set this up. I didn't do that intentionally. It's a good use for polls. Yes, all default settings for free cluster. That's correct. Just doing free clusters. Don't choose the ones that cost money. I think it's expensive too, actually. I think a paid for cluster is not cheap. I use AWS. That's my default one that I've been using, Alex. Oh, okay, yeah, the default is AWS. I always use AWS. Not that it matters because you don't manage it in AWS, you manage it here. It's just where it actually stores the cluster. Maybe you, I don't know. Maybe you don't like AWS, so you want to store it in Google. I just don't know if the other two provide a free cluster. I know AWS does for sure. I wouldn't doubt that Google does. Azure being a Microsoft thing, I don't know. They might not. I should try to set up in the other ones to see if I get more benefits, though. Like, if I set it up on Google Cloud, do I get a larger cluster size? Because 500 megs is actually a surprisingly very little amount. Especially if I wanted to hook up something like a grinder, where it was like running through the internet and processing tons of data, and then put it back and trying to grind through that data and then store it. I would want to have like a huge cluster to be able to deal with that. I'm building a grinder right now, actually, where it's grinding through images we have in our S3 at work and processing them into new image formats. So I had to build a grinder for that. And that's like, I want to say it's gigs. It's into gigs of data. 6 people still processing. Try to make this wider so I can at least see the things. There we go. 4 people. We're almost done. Unless that's the same 4 people that didn't respond to the last poll, and then we might be waiting a little while. I'll give it the full minute just to see. Did you guys watch the Snyder Cut on the weekend? Not yet? It was really good. I liked it. I thought it was pretty decent. I just hope that he left it open, pretty open, and I really do hope that, they make enough money in viewership from this that they'll want to extend him, money to go finish it. And I hope that he's willing to finish it, because from what I've heard, it doesn't sound like he is. It sounds like he's just done, but we'll see, I guess. Alright, I'm just going to ask, anybody not done and still trying to get it set up before I move on? Speak now, forever hold your peace. Alright, I'm going to take that as we have 4 strays just sitting in the channel. Okay, once you get in here, you will likely have to click... Do you have a cluster already, or do you not have a cluster? Can I delete my cluster? Oh, I can terminate my cluster. Yes, let's terminate the cluster. You have to make one, that's right. Enter the cluster name. Alright. So I'm going to let this shut this cluster down. I should have did this while you guys were doing the thing, because it takes a few minutes for the cluster to shut down. Yeah, it's going to take a few minutes. But once it's down, we're going to just click Create New Cluster. You have to choose where you want your cluster to come from. I think you can choose the locations as well. Oh, no, you can't. No, that's too bad. It's all North Virginia, so I'm going to choose AWS. You can choose Oregon or North Virginia. What happens if we choose Cloud? They have free tiers all over the place, and Azure has free tiers. All right, well, I'm just going to choose North, whatchamacallit. So we get the free tier. Where's the free tier? There it is. Oh, you see, it won't let me select it right now because it's currently processing. What about Google? Do I get... Yeah, you see, it's only 512 megs regardless of who you go with. Sorry, I need my cluster to shut down. There it goes. Alright, we're going to create a free cluster. AWS, North Virginia. Free cluster tier. Yeah, it does take a bit of time. This is where you choose which Mongo you want. So you can only really do backups for paid clusters, so don't do that. And then the cluster name. If you want your cluster name to be called cluster 0, go for it. I'm going to call mine. I'm really tempted to call it something bad, but I'm not going to. I'm just going to call it comp 2068. Actually, I'm just going to call it GC. Ask McKinnon. There we go. That's my cluster name, because it's not your database name, it's your cluster name. Right? What a cluster. I didn't say it, I just said what a cluster. That's all I said. 1 to 3 minutes to create the cluster. So, funny thing, funny little anecdote. When I worked for Mintent, I mean, everybody there, they swear all the time. Everybody swears. It sounds like you're walking into, like, I don't know, like walking onto a construction site, and that's all you hear is swearing. And everybody is like that. Like, our CEO, Krista, is probably the worst. She swore the most. But everybody would swear. Well, the swearing actually wound up in our code base as well. So, like, people would write comments. Sometimes you get variable names with, like, curse words in it. So anyways, one day they were showing some stuff to a client. Yeah, really. And they were showing some stuff to a client, and they caught that there was a swear word in the code, like in one of the comments. And so they complained a little bit. So our CTO came back, and he's like, okay, guys, so you need to go through the database. Sorry, not through the database, through the code base, and remove every curse word from the whole code base. And we're like, okay, well, shouldn't be bad. We had 700 instances of the F word, and that was only one of them. And, like, so many other instances of every other curse word in that code base, and it took a really long time. It wasn't so bad for the comments. It was absolute torture to go trace variable names that people had used curse words on variable names, and then we had to go fix it and trace all through the code where these variable names were. Yeah, you would think, yeah, Control F should fix it, but, like, our code base was well over 2 million lines, 3 million lines. I think it was over 3 million lines of code. Like, it wasn't a small amount of code base. Plus, it's all separated into these microsystems. So yeah, that was torturous. So be careful if you're. I'm a frustrated coder, so I like to swear when I code, and I like to write, WTF is this thing doing and stuff in my code. But I'm always good now. I always go back because I learned my lesson. I clean up and I get my curse words out of there. But yeah, all right. So my cluster is now created. I have this wonderful cluster. The only thing is, though, is I can't connect to it yet. I have to actually do these multiple steps, which is kind of annoying, but that's just the way it works. So the first thing I want you to deal with before we create database access is to fix our network access. So click on network access. Now here's something to understand. You have an include list, which basically says include these IP addresses. You are allowed to use these IP addresses only, which means if you click add IP and you add your current IP, don't yet, but if you add your current IP address, you can only connect to this particular cluster from your home. And every time you switch locations, you will need to add another IP address to it. That's for production, right? If I'm building a production system, the only thing communicating to this will be my application, which will be on a static IP anyways, and then I will connect those two together. So that's totally fine. Or they'll be in a VPC together or whatever, right? However, because this is development and you're likely not always going to be home, you might be at like McDonald's or like some sort of cafe or maybe your buddy's house, you're going to want to click on allow access from anywhere. That will add in the proper CIDR for you so that so that you can connect no matter what. This is like, I don't know what you want to call it. It's the super liberal CIDR that just allows you to do whatever from wherever. And then you can set it up to delete after a period of time. So if you don't want to allow that forever and you're worried about it, you can set it to delete. But I would just leave it as is. Nobody's going to access it unless they have your password, and you're not going to publish your password to the internet. And then click confirm. That will add it, and then it will say you will only be able to connect to your cluster from the following list of IP addresses. And this is the IP address. Ooh, what's private endpoint? That's new. Oh, that's pretty cool. So you can actually configure basically a Route 53 so that you can connect to it. That's pretty cool. All right, database access is a different one. So after you've done that, you're going to click on the database access. And this is where you create credentials to connect to your database. So this is super important. This is not the same credentials you created to connect to Atlas. These are credentials you're using to connect to that cluster. So they're specific. So for example, say you're working, I know you guys wind up with a project management class. Say you decide to use Mongo for your project management class. What you can do is set up credentials for you, and everybody else in your group can have their own credentials, right? So say you have somebody in your group that's just, not the person you trust with code, then you can give them read-only access so they don't accidentally, blow away the database or anything like that. But it gives you control, and you can set all that up. So what I'm going to do is I'm just going to choose password authentication and then choose my username. So my username, I'm just going to use Sean McKinnon for my username. And then my password, you can choose whatever password you want. It doesn't matter, right? Just call it whatever you want. Maybe I should choose something that I'm going to remember. There. That works. You can also just auto-generate it too, but what I've found, auto-generate's weird because unless you click show and then copy, it doesn't copy it. So that's kind of the annoying thing about it. So you have to auto-generate, you have to show it, and then copy it. Otherwise, it won't copy properly, and it won't store it properly. It's some sort of glitch. Maybe they fixed it, though. I'm going to try it. Auto-generate, copy, and then I'm going to come over here where you guys can't see things and paste it for myself, and we'll see what happens. Oh my god, what happened here? Ah! Don't click off. Say that. Don't click outside the window. Auto-generate, copy. There we go. Read and write to any database. Yep, that's totally fine. Restrict access to specific. Nope, doesn't matter. Temporary user, doesn't matter. And then just click add user. And that's going to create your new user account. And now this user will be able to access any database inside the cluster and be able to create new databases in the cluster as well as access the data inside those things. So you have kind of a few different levels with the databases in Mongo. You have a cluster, right? So you can think of that I don't know what you would think of it as. It would be like your RDS that you would set up in Amazon, right? Or like a MySQL server, right? So that would be what it is. That's your cluster. And then you have your individual databases that you can create. And you can do the same thing in Mongo, but it's slightly different because in Mongo you can actually create the database when you write to it. So you don't need to predefine the name of the database ahead of time. You can just, as soon as you write to it, it automatically creates the database. So not like in MySQL where you have to actually pre-set up your database and pre-set up your tables and stuff. This happens automatically for you. We don't have tables in our database, right? Instead, in our database, we don't call them tables, we call them collections. So collections are a collection of different values, basically, your resources, right? And then you have documents. Documents are like your rows in a database. So database is database, collections are like tables, and documents are like rows. That's the easiest way to think of Mongo. Okay? So that's cool. We've got all this hooked up. Now let's go see if any of this actually works. So I'm just going to minimize and keep it kind of open. I'm going to open up my file explorer here. I'll just go right to the comp 2068 folder. And I'm going to work in my live lessons directory here. And I'm going to right click and choose to create a new folder. And I'm going to call it lesson 08. Once I've created that folder, I'm going to double click and I'm going to right click on it and choose to open with code. Right? And then I'm going to right click on it again and choose Git Bash here. If you're not using Git Bash, that's fine. It doesn't matter. Just make sure you open a terminal in the same space as where you're putting your lesson 8 files. I just want to initialize our project for tonight, so I'm going to do, does anybody remember what we do? How do we initialize a new Node application? Yep, we're going to use init. So it's npm init, and if you do -y, then you don't have to do all of the extra stuff, right? It just automatically fills it out. So npm init -y. And I will paste that in the chat. So if you did it correctly, inside your project folder, you should see a package.json file. We're going to create our new file called index.js, and that's going to be our entry file for our application. I'm also going to drag this over a bit because it doesn't need to be 20 feet. We're just going to set up our application super quickly. So last week we took a look at all the different pieces we needed in order to have a working application. We've done this twice now, so we're going to do it together a third time. We're going to need Express. We're going to need cores at the bare minimum. Those two libraries we will need in order to create our application. So let's install those. So npm install Express space cores, and that will install both of those libraries for us. So I'm going to hit enter, and off it goes. And sure enough, I have a node modules folder now, so I know that those were installed, plus I have a package lock file. So that was npm space install space express space cores. I included the command inside the chat window there, so make sure if you're getting lost or having difficulty following along, look there. All right, so our next thing is to actually create our Express application. So the very bare minimum of what we need is the Express library, which will give us the ability to actually create the Express server. Right? So that's one. We need to create an app. Whoops, sorry. It's const app equals Express. So that creates the app, or instantiates a new app for us. Then we need to actually set up a listener. And we are going to deploy this application to Heroku when we're done with it. So we should abstract the port. So we'll set it up as port 4000. And we're going to basically say, listen to process.env.port. Actually, no, that's what we're going to do. We're going to create that variable instead. So we're going to say listen to that port, and then we'll create a callback, right? And the callback's super simple. It's just console.log, and we'll give it a template string. Listening on port, not prot, port, and in there goes the process.env.port, like so. So I'm just going to separate these so you can see. I know it's a function call, so it's going to seem kind of bizarre syntax, but this is pretty common in working with Node to see this, just because it makes it a little bit easier to read. So that's the super basics of our server. However, because we're building an API and we are likely going to encounter issues with cross-origin requests, we need to also set up cores. So the way we set up cores is we inherit it first, or not inherit it, sorry, we require it. So require cores, right? And then we register it as middleware. And there we go. So now we have an API that is accessible from the World Wide Web, like in Hopscotch. Go us. So right now we're going to have an issue because process.env.port doesn't actually exist. We'll need to make sure that we create it in order for us to be able to connect to it. But before we do that, we should set up our package JSON file so that we can actually create the starting script for it. So I'm going to split my window. So over here on the right is the index file we're currently working in case you're still catching up. And I'm going to open up the package JSON file on the left. Right here in my scripts section, I'm going to add in a new script. And I'm just going to call it dev. And it's just simply going to call nodemon index.js. That's all it's going to do. Nothing too extravagant. And if I was to run this right now, it's not going to really work, right? npm run dev. It worked, but it's on port undefined, which means it's likely inaccessible. We need to make sure it gets bound to a port, which we'll do in a second. All right, I'm going to copy the index file and paste it into the chat window in case you're still catching up. There you go. I'll drop package.json over here. And we're going to actually get into something called environment variables. So let's talk a little bit about what environment variables are. So, environment variables are variables that exist only on your computer. Have you guys had experience with environment variables before? Have you used them before? Yeah? A little bit in Laravel? Yeah. So the whole thing about an environment variable, what's cool about them, is they exist only on your machine, right? So the idea behind them is that while you don't want to... I shouldn't say that, actually. They are for use for secure information, right? So when you're looking at storing in information in a spot, environment variables are the best way to do that, because the idea around an environment variable is if a hacker has gotten into your system and can access the environment variable, you're already screwed. Okay? There's no coming back from that. You're already screwed. So if they can access that environment variable, there's not much you can do to change that, because they can also access your code and they can access everything else. There are ways around keeping environment variables more secure, but at the end of the day, it involves a lot of different pieces, and if the hacker can still access the system itself, it's irrelevant anyways, because they can always dig through and get the information that they want. So, environment variables, yes, they're fairly secure. Are they 100% secure? Absolutely not. But they are fairly secure. They also serve another purpose. Often when we're doing development, we work in multiple environments, right? So we have local machines where we're working locally on our machines and we're processing our code and doing whatever we're doing. Then we're likely going to move that to a development server, where the development server, we put our code up there and then other people can look at it and review it. Once it's ready to go to our QA, like to our quality assessment, we'll move it into a staging server, and then the quality assessment team will go and run tests against it and make sure it works. And then once we're ready for prime time, off it goes to production, and that's a completely different environment as well. All four of these environments will all have their own databases, will have all their own services that you might be accessing, have all their own credentials. So instead of having to write new code for each one of those different environments, it's much easier to use environment variables and then simply reference the environment variable in order to access that value. So process.env is created by Node at the time of instantiation of your application, and it has access to any environment variables defined on your machine. Okay, so we're looking for a variable called port that we don't have access to right now because we don't have it defined. So how can we define what port is going to be? So the cool thing is that this is such a common problem that there's a common library that exists, and it's called .env, and it's used in so many different programming languages, it's not even funny. I've used it in PHP, I've used it in Ruby, I've used it on Express, right? That's 3 different environments or 3 different programming languages where I have used .env. I know it's also available for Python. I'm sure if you look, it's also available for things like C# and Java and all these other things because it's such a common thing. So the way .env works, first we need to install it. So we'll do npm install .env, all one word. And that's not dot like the period, it's dot like the word. Look in the chat program in case you're curious on what I mean. So once that's installed, the way we actually access it is, first of all, we want to load it at the very top of our application. It's the first thing we're going to load. So we're going to say require, and we're not assigning it to a variable, .env, right? And then we're going to instantly call the function on it, config, boom, that's it. That's the entire piece that we need to add to the index.js. We have one more piece that we need to add to our application. So just .env.config. I'm going to close off the package JSON file. I'm going to click my Explorer here because we need to create a new file over here called .env. And what I'll do is I'll split my screen here and drop the index file over here in case you're still writing it down. This .env file that we've created allows us to be able to add our environment variables. And so we can actually write all the environment variables that we need here that we're going to use. So for example, we can write the port number here, but we can also write the credentials for connecting to our Mongo instance that we had created before. So we will do both. Right now we'll start with just the port number. The way we write an environment variable is generally the convention is to use capital letters, then an equals, and then the value that you want to add. So the value for me is, oh, numlock's not on, 4,000. That's it. So that's added our port number. Now, if I was to load up our application, as you can see, it's now listening on port 4000. Our .env file is loaded and we're ready to go. So there are some other things that we need to consider. This is all fine and dandy. This is awesome because now we have this like environment variable file where we can put environment variables in. And once we move to Heroku, we can actually use their environment variable to set those environment variable values. If we were to use any other machine, we can do exactly the same thing. However, what we don't want to do is accidentally commit this file to our GitHub because it contains sensitive details, right? We don't want to commit this file, and that's a good thing. So we need to create a new file. I'm going to click over here. Create a new file, and we're going to call it .git, G-I-T, ignore, all one word. So .git, ignore, like so. And then in this file, we actually tell Git what things we want to ignore. Well, I want to ignore the .env. I also want to ignore my node modules folder because those are not things I want to include in my repository. So I'm ignoring the .env and I'm ignoring the node modules folder. And while we're doing this, we might as well initialize Git. So I'm just going to run git init. And now that it's initialized, what you'll notice is that the .env folder or file and the node modules folder are now grayed out inside your project, telling you that they're being ignored. Whereas the other 4 files are sitting green, telling us that we have unstaged changes. So just before we go on our break, what I would like to do is just copy over a file that we had created last week. So navigate to where you did lesson 7 and grab that error handling file that you have in there, errorhandling.js. Copy it and paste it in place. Or do it the right way so it actually works. Drag it in place. There we go. There's the error handling file that we had created last week. In case you can't find it, I will just copy the code and paste it into Slack for you. I just don't want to rewrite it. It's a big file to rewrite for no reason. So that will actually set up our error handler. And then why don't we add the error handling abilities to our application so that it's being properly handled, right? So that happens just above our listener. Adding error handling. And we're going to do a const handle 404s and handle, or no, error handler. Like so, equals require error handler. And then we'll register those with our middleware because they're both middlewares, right? So we'll register both those middlewares. Or you can just use comma and register a whole bunch of them at once. I think you can, actually. I think that's a thing. That being said, I wonder if you could just app use and then require this, because it returns those anyways. And then you would just be registering everything. Huh. I don't know. I don't know if you can. That would be interesting to know. So now if I run npm run dev, everything should still be working. Nope. Got an error. Can't find module error handler. That's because it's not called error handler. It's called error handling. Thanks for coming out. And there it goes. It's listening on port 4000 now. All right, so I will share the current state of our application. Cool, and we will take a small, you know what, let's take 15 minutes and then we'll just power through to 5, 10-ish or whatever tonight, and then we'll call it a night at that particular point. Sound like a plan? All right, let's take a break. All right, and we'll continue on. Okay, so far what we have done, we have our index file already. We have our error handler that we copied and pasted from our lesson last week, and we just pasted it in here, right? So that's all ready to go, and it's all registered. We hooked up our .env, right? So in our .env file, we have one line, just port equals 4000, nothing too extravagant, fairly simple. And then we have our app set up, right? We don't have any routing yet set up. We don't have anything like that. We're not actually going anywhere with this. Not yet. We will. But we don't have anything else set up. Right now it's just the basics that you see here. A couple more things we're going to need to do. We're going to need to at least have our controllers folder. So we might as well create it. And we're going to need a models folder tonight, which is kind of interesting. We didn't have a models folder last week. Or we did, actually. We did have a models folder. We created a custom model last week. So we have a controllers folder and our model folder, and we are set to go. So we need to add some more information to our .env so that we can actually connect to Mongo. So Mongo is the database we're going to use, and it's considered a NoSQL database. Let's take a look a little bit at what we are talking about. Okay, so what is a database? There are several different types of databases, but they share one fundamental purpose, which is to store information, right? Statefully store information. There are three fundamental types of databases that you will likely see in your quest for work, right? SQL, which you are going to see all over the place, considering PHP makes up 80% of the web, and I am sure that the majority of those PHP websites are backed on MySQL, probably because a good chunk of them are WordPress sites. NoSQL, which is Mongo, but it isn't restricted to Mongo. AWS, for example, has a service called Document Databases or Document Store, and what it is it's a Mongo flavor, but it's considerably faster than Mongo, and that's where they do most of their storage. But they also have another NoSQL database called DynamoDB, which is very popular, mostly because its read speed is extremely fast, and its basic write speed is very, very fast. It's the indexing that is super slow, but everything else is super quick on it. There's other like flat file type databases like NoSQL databases that are totally escaping me right now, but there are others. And then there's also distributed file systems such as like Hadoop. What distributed file systems are is they essentially take a look at the file system and then they attempt to create like tabular type structures that help describe the documents inside those folder systems. This is for like large-scale corporations that need to basically create a relationship of data based on the data that they have, being in things like PDFs, documents, videos, images, stuff like that. That's where Hadoop comes in. Likely you won't touch Hadoop. I've never touched Hadoop. I know very little about it, but it is likely that you won't touch it. The other two are quite common, like SQL and NoSQL are very common. You're going to see them all over the place. There are people who debate which one is better, but really it is just best tool for the job, right? So whatever the job is that you're working at, that you have to kind of basically take a look. Does it make more sense to have a relational database for this particular data, or does it make more sense to work with something like Mongo? So in the world of business, they love SQL, right? Because SQL describes business entities, hence the term entities that gets used all the time, right? Which is the tables that are in your database. But like businesses love SQL because it describes the entities. It describes the hierarchical structure of whatever their business is, right? And that's what SQL is great for. It's great for hierarchical structures. So, an employee, right? There's many employees to a company. So a company has many employees. And each of these employees might have many customers. And each of those customers might have many orders. And each of those orders might have many products associated with them. So that one has many or has one kind of relationships, those different types of data relationships or entity relationships are so important when you're working in, large hierarchical type structures. Right? But they're also super restrictive. So if you have these hierarchical structures, when you go to add in new information into them, it can be quite tricky because it requires a lot of taking a look at data that already exists and assessing whether or not that data now needs to somehow be moved or translated in order to support this new information. We have that issue actually at work a lot in the fact that we are working with a large-scale SQL database with a lot of relationships, and every so often we get a new business case that requires us to add data to that database, and our tables are so strictly defined that it's a really big show. Basically, in order to add even just one brand new field, it requires a lot of requests for change. It requires tests to be rewritten. It requires like one field, adding a new field to a database can be a 2-day, 3-day event. So That's the one thing to note about SQL databases. They do slow your development time. However, you do get speed benefits with relational data, right? So if you are doing a lot of relationships in your data, SQL is by far more performant than NoSQL. So when should I use what? Well, for example, if I'm trying to store an organizational hierarchy that is naturally a tree shape of data, then it definitely makes sense to use a SQL or a relational database, because that relationship definitely, like SQL databases are definitely oriented towards organizational or hierarchical data. If I want to store a catalog of products, that's kind of a tricky one. So SQL sometimes it's not bad for storing catalogs of data. I mean, WooCommerce, which is like a very famous plugin for WordPress, works in SQL, right? However, that being said, let's take a look at what defines a product. So a product will have a name. It might have an MSRP, right? It might have some details, and it might also have some different types of pricing options. It might have a price, right? So the problem is, though, is when it comes into taking a look at what the details are. Not all details are applicable to all products. It depends really on what the product is. So, for example, a product has a color. Okay, well, that's kind of true, but what if you consider a service as a product, right? A service doesn't necessarily have a color. So that field would be blank and not relevant to that particular product. Or maybe the product has dimensions, right? Width, height, and weight. But what if the product is a fluid? It wouldn't necessarily have width, height, and weight, right? It might have weight, but it won't have width and height. Then you have to actually record volume. So that's different. So these different specifications, the way the databases are set up, there isn't a lot of flexibility to define those specifications uniquely to each product. And yet you still want to be able to have some kind of constraints around it where it's like, well, this product type is this, right? And you could do that. You could go down that road where you have a different table for every product type. Okay, well, if I'm storing computer parts, they go in this product type. And if I'm storing liquids, it goes in this product type. And if I'm storing services, they go in this product type. But the problem is because there's so many different products, you're always going to encounter another scenario where you need to create a new product type, right? Mongo makes this very fluid and easier to work with. NoSQL makes creating these as simple as just adding the new field, and off you go. It automatically registers into the database, and up it's there. And the ones that don't have it, you just write logic to basically deal with that. So Mongo versus MySQL, for example, it really is right tool for the job. You just need to identify what it is that you're trying to store and then use the correct database for that particular storage. Same as when you're choosing data structures, right? When you're working with data, you're going to be choosing data structures, and you want to make sure you choose the correct data structure for the storage use that you're doing. All right, that brings us into Mongo and Mongoose. So what is Mongoose? So Mongo is our database. That's where we're going to store our information. Mongoose is called an ODM, which stands for Object Document Mapper. What its purpose is it takes your data that you would normally put into Mongo, it adds some constraints around it, allowing you to be able to say this data must be in this particular format. It allows you to validate it, so saying that, it must match this schema. It must contain these particular data types, and they must have these certain constraints. It allows you to sanitize that data and normalize that data. It also allows you to create helpers, right? So that you can actually, for example, a very common helper that a lot of people create is full name. That's a very common one, where you take a user's first name and last name, and when you pull it out of the database, you can call full name on that record, and it will automatically return the two pieces concatenated for you. So those can be very handy. Mongoose is really cool because it allows you to apply constraints to a database that is basically known for not having constraints, right? So that's kind of the cool thing. Mongoose is only one. There's a whole bunch of different ODMs that are out there. Mongoose just happens to be one of them. If you're working with a relational database and you want the same kind of control, you want to look at something called an ORM, which stands for Object Relational Mapper. And they exist for every type of programming language out there. If you're working in PHP, I definitely recommend taking a look at Doctrine or at PHP Active Record, which is one of my favorites, though I think it's abandonware at this point. Ruby, Active Record, I mean, that's just the go-to. If you're working with JavaScript and Node, though, and you're working with MySQL, you're going to want to look at something like TypeORM or Bookcase or something like that, right? Basically, ODMs just make working with your data and validating, sanitizing, and normalizing data much simpler, right? They also tend to provide a query language as well, so that querying the database isn't painful. It's not you having to remember all of this brand new query language, like all the different little idiosyncrasies that come with Mongo. You only need to learn the ODM's query language, which is super simple. It's like find all, or find one, or find this, or create one, create all, blah, blah, blah. Super easy to work with. All right, so to work with Mongo, we actually need to install it. So let's clear our screens here. And we're going to run npm install mongoose. So that is npm install mongoose. And that will install the mongoose packages for you. Once we have mongoose installed, we're going to go to our .env and set it up, and there's a few pieces, a few environment variables we're going to need. We're going to create an environment variable called dbUri, an environment variable called dbUser, and an environment variable called dbPass. This is one way to do it. There are a lot of ways to do this, but this is the way that I am going to do it. So the dbUri is pretty easy to set up. You just need to get the URL from the browser. So hopefully you still have your Atlas open, right? You need to go to your clusters, and you're going to click on this little connect link here. And then you want to connect with your application, so the middle option. So I'll walk you through it again. You're going to go to clusters, so clusters. Click on Connect and choose this middle option. The middle option tells you, which driver are you connecting with, right? We're not doing any of these. We're just doing the node driver. The version that you're connecting with, well, we'll do 3.6 or later. And this gives you the code that you need in order to set up the URL. So go ahead and click on Copy. And then what I like to do is paste that in the bottom because I tend to break it apart. I don't necessarily like this piece. You could do it with that piece, but I don't like setting it up with that piece. I like to keep this all separated. So instead, what I do is I take this first chunk and I put it here. And then I take this chunk and I put it here. This piece here where it says my first database, this is the name of your database, and you can literally name it right now. So I'm going to name mine to comp 2068. So I just replaced my first database with comp 2068. This chunk here is my username, so I'm just going to drag it to here. And then the password is whatever password you created. So your password. So this is what the contents of the env file now look like. All right. Yeah, your URI will be different than my URI. They won't necessarily be the same, but the structure should be the same. What's the structure of yours? Let's see here. All right, so you see where it says Mongolio at? That piece you don't need. That piece is your username, and for whatever reason, it didn't attach the password. The rest of it you need, and then the word my first database, you can change, Leo, to whatever you want to call it. All right, I'm just going to move this off screen for a second. I'm going to copy my password into it. And then I'm going to X out of my .env file. Yep. So with the .env, one second though, I'm going to get rid of the password that's in it. Alright, so with your .env, what I did, Stella, is I came to my Cloud Mongo and I clicked on clusters. Okay, so this is what currently is visible. I clicked on connect, and then I clicked on the middle piece that says connect your application. This should say Node.js. This should say 3.6 or later. Here is the actual piece, right? This is your Mongo link that you need. So copy that. You can just click the little copy button next to it. And then in my .env, I paste it. It might help if I describe what these different pieces are. So the it's not called a domain. It's not a domain. What is it called? Maybe it is called domain. I can't remember. So the domain piece is this first part here. This is where you're connecting to, right? Your credentials is this section here, right up to the @ symbol. So the next part. And then your path. Right, sorry, it's protocol. That's correct. You are correct. It's protocol. And then the path part, well, your domain and path, which is domain and path, is the remainder. Okay? Still following along, Stella? Okay? So then, if you look inside this domain and path, you will see this option here, this argument that says my first database. That's the name that you want to call your database. So if you don't want it to be called my first database, not that it matters, you can change it to whatever name you want it to be. So I changed mine to COMP-2068. So that's the name of my particular database. So if I actually broke this down even further, so this would be the domain, and then this would be the path. Okay. So now the only pieces that I care about, Stella, as part of my DB URI, are the protocol, right? Then the domain, and then the path. So I just want the protocol, the domain, and the path. So I'll even move this down. I just want these three pieces. I don't want the credentials because I will actually input my credentials myself. Does that make sense? No worries. So I'm going to post this in the chat just so you guys can understand what the different pieces are that we're looking at. And then I'm going to go change my password. Not that it matters. I usually change it after class anyways, but just in case. Never had anybody be like a jerk about it, but like I've never had a student enter bad things into my database, so it's never been an issue, but you never know. I have had people show up to our class, like Leo caught some straggler that walked into the class in the chat and warned me that they weren't supposed to be in there, so I had to boot them out. So that has happened before, so you never know who's just sitting idly in our chat room. Alright, so let's see if this actually works. So you should have your EMV all set up. And then once your EMV is set up, we're going to attempt to connect to Mongo and see if that actually works. So I'll clear this. And we are going to set up Mongoose. There we go. So the first piece that we need to do is actually require Mongoose. So we'll do a const mongoose equals require mongoose. There we go. That's mongoose. Then we'll call the mongoose.connect function, and we'll set that up. So when we're, unlike MySQL, where when somebody connects to your MySQL application, you perform database operations and immediately close them. Like the second you're done, you close them. That's because you only have so many concurrent connections that you can support, which I now learned recently. It's 150 connections that your database can support, but that increases based on your RAM, which I didn't know before, which is kind of cool. The way Mongo works, though, is every user gets their own connection to your database, right? So when they connect to your application, they're immediately given a Mongoose connection, and then that persists for the entire time that they're using the application. However, I think the way it works is that users can share connections, is essentially what happens. They can't access each other's stuff, but they wind up sharing the connections in a pool. So you wind up with a pool of connections, and it just gets shared. So let's go ahead and set this up. The first piece that we need to do is provide Mongo the name of the URL that we want to connect to. So that's an environment variable that we created. So we're going to call process.env.db URI. That's our environment variable. So that's the URL that it's going to connect to. And then the next thing that it needs is an object. So this is an object as a set of options. One of the options that we need to pass to it, one of the most important options we need to pass to it, is authentication. And that's going to have two pieces in it as well. So we just give it the auth and then another object, literal, a user, so process.env.db user, so that connects that part, and then the password. And these have to be labeled exactly as you see them, or they will not work. Whoops. So once again, the first argument that we give it is the URL, our URI, that we're going to connect to. Then we give it an object literal as a second argument, hence the comma. The first property that we're defining in that object literal is an auth, and that provides our authentication details that Mongoose will use to authenticate against Mongo, our Mongo connection. So these three pieces it's going to use to actually connect to Mongo. Then we have a bunch of configuration options that we need to set in order for everything to work properly. So for example, this URI doesn't get transposed properly unless you set the configuration new URL parser and you set that to true. Then the thing will actually be read properly. Why are you freaking out? Oh, sorry, that needs to move up. There we go. My apologies. Needs to be in the same object here. Wasn't paying attention. Use unified topology, which I can never remember what that is. I love the description. Enables the new unified topology layer. I don't know what that is. I know that it's necessary though. We need it for our thing. Use create index. So that basically automatically ensures that it's going to create object indexes for us, so that when we create a new document, it will automatically index that by its object ID. That's the purpose of that. And it's required for Mongoose. I don't know why it's just not set up by itself. And then use find and modify, and we're going to shut that off, otherwise it causes issues. And then the last piece we need to do on the next line, we're going to chain on a catch statement. And all we're going to do is basically console error it and say, hey, stuff went south. And that is everything, which is, I mean, arguably still quite a bit of stuff. So if that is all good, you should, in theory, be able to connect without an error message. Yeah. So I'm connecting without an error message. Everybody good? Data MongoDB cluster zone complete. Data query serve. The data code is kind of a weird code. It usually means there's something wrong with the actual URI itself. Tends to be the issue. Let's just do a quick. Oh, I wonder if you forgot to set up your, underneath your network access, did you set it so that it's open, Leo? And you set up a user account? Like a username and password for your database? All that's created? Okay. And your cluster looks okay. One second. Can you create me a username and password and private message it to me? And I will attempt your cluster connection. So that way I can see the errors that I get. Just use the Sean McKinnon as a username. Did anybody else have any errors as well? Or is everybody else able to connect? No, we're all good?
Hey Sean, is it okay if I share my screen real quick? I mean, I'm trying to add a new user now, and now the web interface is just not working for me. Can I just show you what's going on real quick?
Yep. Hold on, let me just stop sharing my screen. Alright, go ahead.
So can you see?
Yeah.
Yeah, so when I go here, it just... Oh, of course. Of course, when I show my screen, it works now.
Right.
Okay. Well, let me stop sharing then.
Okay.
Because that wasn't working. It just was dropping every time I tried to do that. By any chance, are there any like passwords length limitations? Because I made mine quite big. Maybe that's why.
There might be. It depends on the actual dealer. Like, depends on who's processing it. So, like the Atlas Cloud might not allow super long passwords. It doesn't need to be anything too, extravagant, because you're just going to delete it as soon as I'm done, anyways.
That's the password, and that's the username. And I'll give you the URI as well.
Wow, there is a delay for the chat window.
Oh, I sent it in Slack, sorry.
Oh, that would be why there's a delay.
Yeah, sorry, I figured you preferred there, but...
Yeah, no worries. Okay. Oh! Your password for your DB pass, if it contains any bizarre characters...
It doesn't.
Like any
just uppercase,
symbols?
Lowercase, and numbers, that's it. I made sure.
Okay. Because that I've had students in the past have that issue. There are ways around that, because you can quote these strings inside the EMV. I connected.
What? I'm testing those credentials now. The ones that I just gave you, same error.
Are you behind any, are you in any weird place?
There's no like network filtering or anything like that, if that's what you're asking.
Yeah, you're not like in an internet cafe or anything goofy?
No.
Do you have any super crazy firewalls up?
No.
That is super weird.
I mean, you know what? Maybe we should put this aside for another time and let you finish the lesson, and I'll try to troubleshoot this, and if not, maybe I'll do it another time. We'll do it another time.
Yeah, sure, that works. Also, check and make sure that all the settings that I gave you are the same settings for the Mongoose connection.
Do you have this on GitHub by any chance? I'm thinking of just cloning exactly what you got, because maybe I got an issue, but so far I can tell everything looks fine.
Nope, it takes 2 seconds to put it up.
Awesome, thank you.
I mean, it's going to have to go up tonight anyway, so... 2068... What the heck is this thing? Oh, that's that weird virtual camera. How the heck do I get rid of it now? Just do that. Alright. There you go.
Awesome, thank you.
No problem. Alright, so let's, did I put my EMV back? Yes, I did. Alright. There we go. So, if everybody else is working, then we'll just leave it at that. Okay. So, we've got our connection. We're connecting to our actual database. This doesn't necessarily mean that everything is working and everything is hunky-dory, though, unfortunately. As much as I would like to say it does mean that, it unfortunately does not. Because we may still wind up with write issues, and if we have those will at least throw an error. What this does mean, though, is that you're not having a connection issue. So that's the good side to it, is that you're not getting the connection issue. Okay? Alright, so next step. Let's see where we are in my notes. Okay. So we added Mongoose to our app. Now we're going to create a new resource. Okay, so we decided on movies and genres. If we look at that from a perspective of relationships, then genres would be the parent and movies would be the child, right? Because a genre can have many movies. A movie, well, in theory, could have many genres. We're not going to make it that complex. We'll just make it that a movie can only have one genre, okay? I realize that's not entirely true. A movie could be a thriller and a horror all at the same time, or it could be an action thriller. But if you want an action thriller, then you'll just create another genre called action thriller. So let's go ahead and take a look at what we can do to set that up. We're going to need to create a new model in order for that to work, right? So in our models here, we're going to create a new file, and we're going to name the file after a single resource. Now, genre is kind of weird because, no, I think genres, yeah, plural for genre is genres. So that's not so bad. That one's actually pretty easy. I've had some in the past that are kind of weird. Like, for example, I don't know if you knew this, but the plural for data, or sorry, no, the singular for data is datum, like D-A-T-U-M, and the singular for meta is metum. And what's interesting, I didn't know that until I started working with inflections that were built into Active Record in Ruby, and I was like, why does it keep changing this to metum, and what the heck is a metum? And that's when I found out that it actually, metum is the singular for it. So, because it has something called a scaffold builder where when you type it in, it auto creates your models for you, which is kind of cool, but then it names them, right? So, and it was naming it metum. So here we go, we've got our genre in there. We'll just create these one at a time, right? We're not going to create them all at the same time. So, yes. Okay, so when we're creating our models, there's a few different steps that we need. There's three, at the minimum, 3 steps that we have to have. The first one is we have to import Mongoose. That's the first step. Whoops. I don't think I've ever hit a minus sign before. That's interesting. Hopefully that's not a new seniorism. And then const and the name of our model, right? So the way we generally name our model is we give it the name that we called the file, so genre, and then we attach the name schema to the end of it. And I'll explain what a schema is here in 1 second. And then the last thing we need to do is export this out. So we're going to do module exports, which is like a default export. Mongoose.model. And then we give the model a name, which we just call it genre. And then the thing that we're attaching it to, which is genre schema. That's super weird. Try destroying your database, Leo. Yeah. Try destroying your database. Oh, works with a VPN. Are you through some kind of super weird, like, internet provider? Yeah. Yeah, you see, then you're over my head. My world of DevOps is pretty crappy. I'm okay. I can, like, kind of manage my way through a little bit, but yeah, you're probably way over my head. Stick to the comfort of my code. Alright. Okay, so the schema. What is a schema? A schema is basically a description, right? It describes data. So the idea behind a schema is that it should describe the data that's going into our database. So when we work with MySQL, we call each of the columns inside of our data, like our table, columns, right? We call them columns, and those represent a particular attribute about our data. So when we think of genre, we need to think of the columns that we would have if we were building a MySQL database. So what columns do you think we would need for a genre? So first I'm going to put a empty object literal in here, and I'm just going to split it apart. So what columns do you think we would need for genre? I mean, name, right? I'll start you off. Name makes sense. We should have a name column. Actually, the ID automatically gets created for us, which is awesome. So when we go to insert this, Mongoose will create something called an object ID for our document and automatically assign it. So unlike where MySQL, we have to actually create that column, it automatically does it for us, which is pretty awesome. Can we think of anything else that we might need for genre? I mean, it's a pretty small kind of thing. Like, what else do you really need besides name? We could do a rating across the genre. Like, we could have a rating where it's like, this genre is horror, and therefore rating is, you know, R. But I guess that doesn't make sense. No, that would likely go on the movie, not the genre. I mean, I think we're done. I think we literally have one column in the whole table. All right. It's not a table, though. Can't say that. It's a collection. It is a collection. All right, so let's fill it out, because we can actually add a bit of validation to it, which is kind of cool. First, we can state the data type that it needs to be. And Mongo allows for a bunch of different data types, a bunch of different native data types that it supports. So Mongo allows for numbers, which is anything, whether it's a Boolean, whether it's a double, a float, an integer, whatever. It's all just number, okay? Because it's JavaScript data types that we're working with. A Boolean, right? So true or false. Strings, right? Totally makes sense. Objects, so you can actually store other objects in. And arrays, right? So you have those 5. You can also create custom data types as well, and then store those custom data types. The only important thing to note is nothing interactive. So you can't store a function. That's not a thing. Okay? You can't store a class or a method. Nothing like that. Those data structures, unfortunately, aren't a part of it. But you can store native data structures or simplified data structures. So we're going to store the type, and we're going to make it a string. And you'll notice we're actually calling the, what do they call it? Constructor, that's what it is. The string constructor. We're actually passing the string constructor to our type. And then required, so we can actually say that this is a required field. And there we go. We've actually provided a little bit of validation. It will ensure that it's a string being stored no matter what. Even if it's a number, it will quote it. And it will ensure that it is required and we don't wind up with it not being added in. Now there is one other thing that I want to add, and I always forget how to do it. I know it involves dupes. I always remember it with users, but I always forget it with every other thing. We want to make sure that when they add the genre, that they don't add the same genre over and over again, because that's a pet peeve. I always find that when we're doing like lessons inside Georgian college courses, that we tend to be like, show bad things like that, like we're not making the user unique when they should be, kind of thing. We need to make sure that we are doing that, right? Like, if you were to do this in production and you didn't put uniqueness on that, that would be the first thing that your CTO would call you on, or your team lead would call you on, is why didn't you apply uniqueness to this? So we need to make sure it's unique. So I'm going to do Mongoose unique field. Yes, I'm typing, and I'm now in Stack Overflow, just so you guys know. Sounds ridiculous, but that's where I am. Okay, so that's what I thought it was. So it's unique true is the first thing that you do. So you have unique true, which says this column is going to validate and based on uniqueness. Has to be unique. And then the last thing we want to do, just in case somebody like inserts directly into the Mongo database some records, we want to add drop dupes and set it to true. And what that will do is the second we execute our application, it will actually scan the database and remove any duplicates for us. So if somebody's being cheeky and automatically inserts those records directly using Atlas, because you can do that. In Atlas, you can actually add new records to it directly. You just simply go to clusters, click on the database once it gets created, and start adding in your own things to it. Actually, if I click on collections here, I bet you we already have our database. Nope, not yet. But you could create it, and then you could add fields to it. So, yeah, no, that's a problem. So we want to use unique, true, and drop dupes, and that will prevent any issues from, duplicate kind of, it's duplicate fields being added. The last thing I would like is some timestamps. So a common thing when you're working with model view controller systems is a lot of them already have a built-in timestamp function, so that every single record that gets created automatically gets added at created at and updated at timestamp. The nice convenience of that is it kind of gives you a little bit of an audit trail, so that when you're trying to establish when something was created or when something was last manipulated, you have these two dates that you can go and look at. Now, obviously, if you're building a large application, you would want a more robust audit trail where you can actually, see who did it, see who the offender was, and all that kind of stuff. But at least this is fine for now. So we're going to add that. So the way this gets added is kind of a bit different. The schema describes the different pieces about our genre schema. However, any extra little pieces that we want to add get added as a second argument to the schema function. So you'll notice I've added a comma here, and I've added another object literal. And then in here, we type in timestamps, and we set it to true. And so that will create the created at and updated at timestamps for us. So let's see. Is there anything else that I want to add? No min, no max. We don't need any of that. We have our required. Oh yeah, that is a point. So Mongoose does tell you that the unique option is not a validator. So if you attempt to add another, so say we have horror in there and we attempt to add horror in as well, it will actually add it and then drop it. The drop dupes will add it, which makes me wonder why unique is necessary. So we want to add something called a custom validator then. So we're going to add a validator that basically checks to see if it's already there, and if it is, then it drops it. No, sorry, then it will warn you and tell you that it's already there. This is going to be interesting because I haven't written one of these. I wonder if we would just use a find to do that. All right, so we're going to do validate, and validate takes an object. And then in the object, this is kind of weird, you pass it a validator, which is your function, and you want to pass a standard function because you want to be able to call this, and this is not bound to arrow functions. This, being the genre schema, is what we want to be able to access. If we were to pass an arrow function, this would be the global object of our node application, which is not what we want. And you can't even bind the proper value of this to it either. So you have to do it this way. You probably have no idea what the hell I'm talking about. Just use normal functions. Don't use an arrow function when you're building your validator. However, this one we can. This one is just our message. Right? So the validator function that we're going to build is basically going to check and see if our value is unique, and if it isn't, then we're going to write this little nasty message. We're going to say props, so this we're using a template string, props.value is not a unique, or we'll just say already exists. That's even better. Already exists. There. In the end, I got there. And then our validator function, we're going to need to check to see if the record exists. And if it exists, then we want to basically say, no, you can't do this. So I want to check and see if we actually have in Mongoose. Yes, I'm looking at documentation. I don't remember this stuff, right? I don't commit it to memory. Check if document exists. Because they do have an exist function in Mongo that does make things a little easier to work with. Okay, so that's Mongo, not Mongoose. We want Mongoose. Connecting, building a schema string. Yep. They're using the find by to do it. Oh, it looks like everybody's using the find. Okay, so I guess that's what we're doing. So we're going to say this dot find. I am a bit nervous that this is actually the current instance. I think it's the current instance, so we can't do that. So we actually need to do genre dot find, like that. There we go. So genre dot find, and we want to search for the name field and give it the value. So we're going to basically check to see if it exists. And then if it does, we need to throw an error. So we will do... Oh, this is terrible. Why don't we just add an async here? We'll do it with async so we can call await. Actually, we can just return this. Even better. There we go. Because if it doesn't exist, it will return null. And if it returns null, the validator will be false. And then this message will actually get outputted. Yeah, so that's kind of weird, right? So genre is being defined by the model system down here. I think I actually need to call genre schema. I'm looking at this dude's notes here, and he called it user, but I think that might be wrong. I think it actually needs to be called genre schema. Yeah. I hope. Yeah, that's weird. I'm going to try this. I'm pretty sure I've done this before. I've done this before with users, and I think I used this, and it was reference to the model service and not the instance of the record that I was working with, the document that I was working with. I mean, we'll find out short enough, right? So let's wander through this. Let's ignore validate for a second and wander through the rest of this. We required our Mongoose module, right, that allows us to be able to create new models. This is the thing that gives us the power for creating new models. We define a new schema, and then we describe our schema, right? That's what this whole wonderful giant block is about. It's all describing the schema. So we're like, hey, I've got a schema, and my schema must have a name, and that name must be type string, and it's required, so you got to put it in there. I would prefer it's unique, though it doesn't really mean squat. But if you do enter it and it's not unique, I'm going to drop it. You just won't know about that. I want you to validate it, right? So we're going to validate it. We're going to use this crazy validation function that Sean wrote that we aren't 100% clear on whether or not it will work, but we're going to assume it does. So this validator function is basically going to perform a find, and we're going to use this quite a bit in a bit. But it's going to find in our model any document that exists that has the name with that value, and value happens to be the one that the user is currently trying to create this with. If the validation fails, then we're basically going to say, hey, this already exists. Props, just so you know, are the properties that the user passed. I don't know why, and it really annoys me, that value that they use in the function isn't in the same data structure that props is. Why would this not just be props? That to me would make sense. Yeah, my head hurt too. Validation inside Mongoose is not simple. It is super ridiculous. So you have a validate property, then you give it an object with two properties. The validator function you want to validate against the data, and then the message you want to say when the data fails. All this schema is for is basically taking the value the user is trying to add to the document and saying, does it meet these requirements? And if it doesn't, then it drops it and throws an error and tells you that there's a problem. So I think the easiest way to better understand how this model is working is to create a controller and attempt to create a genre. And then we'll call it a night so that we don't break Leo. All right, under controllers, right click, and we're going to create a genre controller, but we're just going to call it genres with an s.js. And I will copy the model here and I will share it, because I know there was a lot of parts to that. There you go. I'm still recording, right? Yeah, that would be bad. I am still recording. I have a backup just in case. So if this all fails, I've got WebEx recording in the background. Just WebEx doesn't strip out the breaks. I can't pause during the breaks, which kind of sucks. But all right, so in our controller, just like we did last week, we're going to import our model. So we're going to call it genre with a big capital G equals require. And this is where we're going to dig through to our models table. Why is it tab 9's being stupid? There we go. And I think we'll just do some simple ones, right? We'll just do two actions. We'll have a import act or an index action. And we're going to add async to it because any actual model work we do is going to be asynchronous because it is input-output operations. So they will be asynchronous. And then I'm also going to export the create function. So just two for tonight. And just two for this one. So it's really create that we kind of want to do first because obviously we can't do anything without data. So we want to create a new genre and add it to our database. And this is where life gets pretty simple. We're going to add our try catch that we talked about last week, right? That takes the error. I'm going to hold down my Alt key so I've got two cursors blinking here and I hit enter. And all catch is going to do is next the error for me. Incidentally, if you wanted to write that in shorthand, I think you can get rid of these curly braces. Oh no, it doesn't support it. That sucks. That's weird that try doesn't, because ifs do, for each do, all the other guys with blocks do, but not catch. Catch does not. Catch gets mad. Alright, so our create is going to be very simple. It's going to need access to the request object. It's going to need access to the response object, and we're going to need the next object. I mean, we're literally going to need those in everything we're working in, so we'll add it to the index as well. And I mean, this try catch we can add to the index too, because it's literally the same. This is why scaffolders exist. Because when you write this same block of code every single time, scaffolders make this kind of stuff easier. Because it auto-generates the file and scaffolds it all for you. So I'm just going to collapse the index because we're not working in there right now. We're working in create. It's funny because as we go through this stuff, it always seems like I'm stalling. All right, you ready? Let's do it. Why did I use requests with like the full... Sorry, I'm distracted. First of all, let's grab the data from the request body. So the user is going to submit a request to create a new genre, right? And that's going to come from our request body. So to grab that data, we need to store it somewhere. So I'm going to create a destructured object and store the request.body in it. And the only thing I'm looking for from that is called name. So it doesn't matter what else they pass in that request body, I'm not going to accept it. The only thing I'm going to accept from the end user is the name property. Now this request.body command is not going to work. It's actually going to break. And the reason it's going to break is because we need something we need another piece of middleware called the Body Parser. What the Body Parser's purpose is it takes a request body from a user and then converts it into a JSON object and transmits it on. Actually converts it into an object literal and transmits it on. And we need that, otherwise we won't be able to see what the request body is, or we'll have to parse it ourselves, which is silly. I'd rather just parse it with the actual system itself. So I'm going to just split my screen so that this code is still over here. And I'm going to go to index.js. And I'm going to open up my bash shell. And I'm going to kill my bash shell. Because we need to install the body parser. So I'm going to do npm install body parser, all one word. At least I think it is. Actually, now I don't know. Hold on. I forget if body parser is one word or not. It is not. It is 2 words. Good thing I looked it up. There you go. So we're going to install the body parser. So now our body parser is installed, and then inside our index file, right up here where we're doing stuff with cores, we'll add the body parser. Because, I mean, it doesn't really matter where we do it. We just need it. So people tend to do it like this. And then we do app.use, and we tell the body parser how we want to process our data. So we want it to process JSON. And then we want to use URL encoding. So body parser.URL encoded. And that takes an object, and it's extended true, like so. So this is interesting. Why is it... deprecated. Body parser is deprecated. The declaration was marked as deprecated. That's interesting. I wonder what it wants you to do instead. Huh. That's kind of interesting. I'm not going to waste your time figuring that out, though. So add that into your index.js file and save it. Whoops. That was Shift-S instead of Control-S. Let's run my dev thing again. So again, what body parser is going to do, it's going to take the incoming request body. So when somebody submits a form, right, a post request, it's going to take that request body, convert it from the whatever format it's in into JSON, and then it's going to pass it through. What the URL encoder does is it takes any query strings that the person may have added and turns them into parameters. So both are kind of necessary, though I am kind of curious if this is actually completely like deprecated, what we're supposed to be using instead. I haven't built a new server in a long time. For work, I mean, not for school. All right, so now with this create, we're basically pretty close that we can actually start filling out the rest of these pieces. I've got my name, right? So now I just need to finish off my controller action. So I'm going to create a new genre by calling a wait genre.create, which takes an object as an argument. And I mean, we're only passing name. You can go name : name if you wanted to, but you can see the redundancy in that. I'm just going to say name, right? And then after that, we're just going to send back a response. So the response is just going to be response.status 200, right? So that gives them the status. And then we'll send back JSON. And the JSON, I mean, it doesn't really matter how we want to do this. We could just send back the created genre, or we could send back a nice message. I think sending a message is nice. I like that, right? Everybody likes to receive a message. Genre was created successfully. And then the status is success. They'll already have the status code. and then the genre that we created. So a few different pieces they'll get back. And with our error handler should respond with the proper error in JSON format for them. So if they get an error, they're going to get an error, right? So let's see if this works while you guys are typing that out. We'll go to Hopscotch. You could use Postman as well if you guys have experience with Postman. So I need to send this as a post request, and it's not going to work. Why won't it work? What am I forgetting? Why won't any of this work yet? I've got the model, I've got the controller. Yeah, I'm missing some routes. We kind of need the routes. Is anybody still writing code from the index page, or can we start working on routes? We good? Alright, I'm going to expand my screen, and we will create the few files we need. We need the routes.js file at the root of our folder here. Right? So that's super important, because we'll need to create our routes. There we go. And that's super simple, right? It's just module.exports equals the router that we pass from the index file, and then whatever routers we're going to require, and then we return the router. So we're going to need to add in our router for the genres. We'll have to create a route for the genre. So we should create a new folder called routes. And we should also make sure this file is named correctly. There, that's better. In our new folder called routes, we're going to create a new file in there and just name it after our genres, right? So we'll call it genres.js, and that's our routes. And then that's going to bring in our controller actions, like we saw last week. Right? And the controller actions we're going to bring in, I'll just separate this, our index and create for now. And then the same scenario as we just see on the left-hand side there. Module exports equals router. Nice little arrow function. And then whatever routes we want to define. So the only route we're going to define right now, and we'll likely only get to tonight, is the create route. And the way I'm going to set up this path is I'm going to use the name of the resource, which is genres, and then the name of the action, which is create, and then that's going to point to create. Does that make sense? So I have my genres routes. I have my routes.js. Now in the routes.js, I just need to require that and then execute it. So require routes, genres, and execute it passing in router. All right. So this is your routes. This is at the root, routes.js file. And then this is the routes genres.js file. So far we have created a model that allows us to be able to describe what a genre is going to look like to our database. We've added some validation in there that we have no idea if it's going to work or not, but we're going to assume the best. We've created a controller with two actions. We have an index action that we have not stubbed out yet, but we do have a create action that is going to create a new genre and pass it into our database. It's going to pass it to the model. In order to facilitate activating that create route, we have created our two routes. We have our resource specific route, right, for the create method, and it's a post, right, because anytime we're doing any data manipulation, we're posting to it. And then we also have our routes composition file that actually brings in all our resource routes and composes them all for us. In addition to this, we added the body parser to our index file. The body parser's purpose is to take the form data that a user submits and convert it into JSON so that our application can understand it. That's literally all it does. The other thing we need to add to our index file is these routes. We haven't added those yet. So the routes, we want to go after all of our essential, most of our stuff, like the Mongo connections and stuff, but be above the error handling. Right? So we want to require our routes here, and then in our index file, and then we're good to go. So we're just going to first require the routes. So this is our composition file that we're requiring, right? So that's this file, the root one here. And then we'll create the router and pass it in the express.router. And so what's happening there is that gets passed to the composition router, and then that gets passed through to each one of the resource routers. And all they're doing essentially is adding new paths to it, and it's just building a big laundry list of paths. And then the last thing, the absolute last thing, is app.use and the router. So now this is registered to our application. We have the routers, we have all the routes, we have the controller, we have the model, right? So, again, it sounds like I'm stalling, but I'm not. We're going to actually post to it. So the URL is no longer this URL. It will be genres, right? And /create. I mean, I don't generally do /create, so I'm actually going to get rid of the create part. It will just be /genres. Create is implied because it's a post request. We're going to need to add some data to it, though. So we have this, we have that, we need a request body. So I just click add new here, and it gives you the option to add a key and a value. So the key is name, and the value will be, let's do the value of psychedelic. Oh, you know what? Let's keep it simple. Or, there we go. We'll just keep it nice and simple for now. Oops. Oh, why did I click that button? Let's try that again. Genre, and then, oh no, that's not what it is. Name, and then horror. There we go. And don't click any other buttons. There. Okay, so you have your URL. Don't worry about giving your request a name unless you want to. Should be application JSON, which is fine. And then the request body, just click that add new, and then add a name and the name of the value that you want. Now I'm going to click send. I get a 500 server error. There you go. There's that validation issue. Genre validation failed. Name, this find is not a function. Oh, okay. So this dot find is the issue. So that's kind of what we were saying before, that this might not be connected the way I thought it was. So if I jump to genre, I know this is genre, but it's like, I don't want to call it genre because I haven't actually imported the model of genre. If this works, that feels like some serious magic. Yeah, it didn't work. I didn't think it would. Genre is not defined. All right, we do need to be able to just establish if this is unique or not. I'm not sure how to do that off the top of my head. What we could do, though, is why don't we just see if it actually works even without the validator. So I'm just going to remove the whole validation option. I'm just going to see if it will work either way. So now I'm going to create this, send. So there it goes. It created the genre, and this is what it returns. So it returns the ID. So like I was saying, Stella, we get the ID, the object ID. It automatically creates that for us. Here's the name and horror that we added into this, right? So that's the genre. And then we have our created at and updated at dates. Plus we get this underscore V, which I can't remember what this is. I forget what that's a part of. But we get all the different pieces that we need. I think that might be the validation. So if I send it again, it shouldn't create another one. Oh, you see, that works. Duplicate key error. I mean, that's good enough, right? You tried to add a duplicate key, so now you're getting a duplicate key error, and the duplicate key is whore. So you can't add it twice. You're getting a 404. If you're getting a 404, it's likely the URL that you're passing. So the URL that you want to pass, Stella, is this one, and you're posting to it. So make sure you've got this set to post and not get. Because if we get and hit send, you'll definitely get a 404. So you need to post to it because the HTTP method actually matters. See? Error. So this is where you could do like horror, thriller, right? There's my second one now. Good. Action. You could have tons of these, right? Action. Do you guys want to go, or do you want to take literally 3 minutes and write the index action? Are you good with writing the index action? Or do you want to save it for next week? I mean, it's like literally 3 minutes. 1 minute to write the action, 1 minute to write the route. Yeah, let's do it. All right, so under our genre controllers, right, let's scroll up to where the index is. And I'm just going to move this back this way a bit, like so. So that's genres. Where's the routes for that? There it is. All right, so here's my routes on my left side. Okay, so index, super easy. All it is const genres, right, equals genre dot find with nothing inside of it, just dot find. That's all it is. And then we're going to response dot status with a 200, and we'll add dot json to the next line, and I'm just going to literally pass genres right in. That's the whole index. Now all we have to do is make sure that we have the route for it, because if we don't have the route for it, we're going to have an issue. So let's create the route. Here, I'm just going to extend this a bit so you can see what's going on. So the router dot get this time. Still genres though. And it points to index. There you go. How long did that take? Not even 3 minutes. It's 5:29. So now if I just change this from post to get, I don't even need to clear the body. Click send. Converting circular structure to JSON. Did I do something silly? No, that's correct. Genre.find, unless I did it wrong. Literally wrote one of these the other day. Oh, a wait. Sorry, I forgot a wait. We need a wait there, otherwise it is a problem. Boom, look it. I've got 3 records. Oh. Somebody snuck into my office. I didn't even notice and dropped off an ice cap. I was enthralled with our lesson. Wasn't paying attention. This is how I'm going to get murdered, right? Because I don't pay any attention. Somebody will sneak up behind me and then you guys will all be traumatized. Alright, so let's talk about what we did. We added an index, right? All it's doing is literally calling the find method. Super simple. find will return literally everything unless you give it some arguments. So if you gave it some arguments, it will basically filter its find. But if you give it no arguments, it just takes the whole database and brings it down. Then we create a new response with a status of 200 and pass the genres as JSON. We created a route, super easy, right? Just points as a get to the index. I do like to sort these. I like to make sure my get requests are at the top and my post requests are at the bottom, but you do generally create the create one first because that makes sense. So if you're talking to the other 15 people in this class or 25 people in this class, I think there's 40 people in this class. If you're talking to the other 25 people in this class, let them know that they should watch the YouTube video. There's a lot to cover. The good news is we're going to do this about 6 more times, 7 more times, 8 more times. So you guys are going to get really used to this. You'll be able to create a whole API in your sleep. So next week what we'll do is we will finish off genres so that we can update and delete genres, and we can access just one genre, okay? Then we will create our movies table, which will have a lot more fields. So what I'd like you to do between now and next week is think about the movies that we're going to add, right? And think about what fields make sense, right? Like, so name, obviously, or title. Title makes sense. Rating makes sense, right? Maybe length of the movie. Maybe the color, like color saturation, whether it's black and white or in color. Maybe it's in Technicolor. Think about the different fields that we could have. I want to add about 5 different fields, and I would like them if they were kind of varied in data types, right? So, you know, like a couple could be strings, but maybe some numbers, maybe a Boolean option. So think about some fields for next week, and we'll add them in. There's no lab, no quiz for this week. There will be a lab for sure next week, though, so keep that in mind. And it is a hefty one. But yeah, any questions? No? All right, so I'm here to help you if you have 404s or things are broken.